Hi, everyone. Welcome to Chapter 8, Segment 3. Today, we're going to take a look at the total approach to profit maximization and calculation of that. There's also a marginal approach to profit maximization and calculation, where we'll use marginal revenue and marginal cost. But today, we're just going to look at the total approach to profit maximization and calculation. So I'll take us over to the spot on the screen that we need to look at. If you just give me a second here. We can start off by just defining what total profit is. And now before we define exactly what total profit is, we have to understand what total revenue is and what total cost is. I think we've got a pretty good idea. Total revenue is just the maximum or the total amount of revenue that the firm has received, and total cost is the total amount of fixed costs, variable costs, opportunity costs that the firm incurred in its production. So the difference between those two, we're just going to say, is total profit. And you notice the little pi symbol, that means profit. So we're going to discuss a few other things that go along with this. Break-even output. If I was to ask everyone, hey, what's a break-even output? Well, output is a quantity. So what's a break-even quantity? What are you doing when you're breaking even? And it's just, well, you're not making any extra profits, but not making any big losses. So your sales revenue is just covering your fixed and variable costs. So you pretty much are breaking even. And that includes your normal profit or your opportunity costs. You're covering that as well. So a break-even output is where your economic profit is actually zero. So let's take a look at this. On the left, you see we have our output. And we're ranging from 0 down to 9. Here's our price. And remember, that's average revenue and marginal revenue in this industry structure, perfect competition. So there's our price of 20. And then we just take our output times our price to get total revenue. And that ranges from 0 to 20 to 40 to 60, all the way down to 180. In this last case, the output is 9 times 20 is equal to 180. So the total costs were just given, and they happen to go from 30, 48, 58, 60, 63, and the total costs just keep rising. Remember, those are fixed, variable, and opportunity costs. So total profit then, well, all we simply have to do is take our total revenue and subtract total cost, and that should give us total profit. And in this case, if we subtract total cost from total revenue, we end up here at minus 30. So we're making a loss. Here we've got 20 minus 48. Well, that's minus 28. We're still making a loss. At an output of 2, way over here is 2. We've got total revenue of 40, total cost of 58. We're still making a loss of 18. And then what happens next if we decide to maybe produce the third unit of output? We come across, we've got total cost of 60 minus, or subtract that from a total revenue of 60, that's 0. So that's basically a break-even point where our profit is 0. So let's just go down this profit column, coming down here, and I see another 0 down there. Here's our first break-even, and here's our second break-even. We notice that if we were to produce an output of 8, then our total revenue is 160 minus our total cost of 160 equals a break-even of 0. So these two quantities, quantity of 3 and quantity of 8, are our two break-even quantities. Well, I want to use this total approach using our total numbers, total revenues, total costs, to determine where's my best profit. My maximum profit, going down the profit line, occurs here. There's a 30 and a 30. We'll take the second one. I always take the second one. We'll explain that at some point here. That's at an output of 6. So notice that you don't make your best profit by producing all you can, because if you're producing 9, you're actually making a loss of 40 over here. But if you're producing an output of 6, your total revenue is 120, you subtract your total cost of 90, and that gives you a maximum profit of 30, and that's your profit maximum. So this is your profit maximizing quantity using the total approach. Okay. So let's graph these things. And if you notice total revenue right here, that's just, the blue line is just price times quantity. Total cost, well, that's just plotting the total cost curves. Down below, total profit, well, that's total revenue minus total cost. So if we take this blue line and subtract the red line, down here, the total revenue minus total cost is higher, so total profit falls below zero, this line down here. In between, total revenue is greater than the red total cost line, so we're making profits in between there, so this total profit line is above zero. And then we go back over here where it's orange and we see total revenue again falls below total costs, and we end up showing a loss over here. But notice we've got break-even points of 3 and 8, break-even quantities. And right here at an output of 6, that's our maximum profit. That's the highest that our blue line is, right there. So that's how we find maximum profit. We just take the difference between total revenues and total costs and see the quantity that's A, break-even quantities, or B, the best quantity to produce your maximum profit. Now there's a few examples here where I'll just click through them, but you should go back through the slides and take a look at yourself. Here we've got price times quantity and it gives us the total revenue. We take total revenue minus total cost and it gives us the total profit. At that point, once we figure that out, there's our break-even profits of 0. That's at an output of 5 and 7. Those are our break-even quantities. Our maximum profit occurs at 20. That's at an output of 6. And we just get that by taking total revenue minus total cost equals total profit. So make sure you can work through that calculation. There's the rest of it. And we'll pick up next time looking at the marginal approach to profit maximization.